So in this course we're gonna study the motherboard with power on. Okay, so here what we have here, we have a motherboard, as you can see. So we have here the power jack cable. Here we have basically the power jack plug. Okay, here we have the power jack with extension with this cable. In this cable, as you can see, we have 4 wires. So 2 red wires for 19 volt. This is high lines. Okay, and 2 black wires. This is basically the ground. Okay, so these wires means these 2 pins over here. Do you see this arrow? Means here you can measure 19 volt, and these 2 are these 2, means here we have the ground. Okay, so basically here we have the plug. Okay, and over here this component, as you can see here, we have the charge circuit. Do you see this circuit? This is basically the charge IC circuit. Here we have inductor, we have MOSFETs or switches. As we have seen in previous videos, these 2 switches basically they will take 19 volt and deliver 19 volts. Okay, we're gonna see all this. Here we have a Zener diode, we have resistors, we have some transistors, etc. Basically here we have protection component. Okay, and this one, this is basically inductor. Okay, so once we connect the adapter here, we can then check whether we get here 19 volts or not. So for these 2 inductors, this circuit basically is 3 volt 5 volt circuit. We have 2 inductors. One inductor is for 3.3 volt and the other for 5 volt, and we have the control IC, the 3 volt 5 volt control IC, and we have 2 capacitors. Okay, so in every channel you will find inductor, capacitor. Okay, and here we have test point or the pad, inductor, capacitor, test point, and of course some capacitors. Okay, now once we connect the adapter, as you can see here, this is the 3 volt 5 volt or 3 volt and 5 volt circuit. Okay, so of course we can go directly and check 19 volts and track the voltage over here, but I will give you a trick that you can use to gain time and don't waste time while troubleshooting any motherboard. Once you connect the adapter, go ahead directly and check the 3 volt and 5 volt. Okay, don't waste time here, because if you get here 3 volt and 5 volt, means here is good. But if you didn't get here 3 volt and 5 volt, means you should go back and check the input circuit or the charge circuit. Okay, so to check the 3 volt and 5 volt circuit, what should we do first? So here we should put the multimeter, okay, of course, to DC voltage. So because the adapter deliver 19 volt to the motherboard, then we should put the multimeter to 20 volt, the high voltage, that the voltage that the adapter deliver to the motherboard. Okay, then we should put the black probe of the multimeter, as you can see here, in the ground. Everywhere in the motherboard you will find ground. Here we have ground, here also we have ground. Okay, and of course for in the ceramic capacitor you will find ground. Okay, here for example we have ground. Okay, then you can use the red probe to check these 2 inductors. Okay, so for example, as you can see, this inductor is for 3.3 volt. That's why we get here 3.3 volt, as you can see in here in the schematic. Okay, so we have here 3.3 volt. So we have the inductor, as you can see. This is the inductor that we have tested. This inductor is this inductor. Okay, and here we have an electrolytic capacitor, as you can see. Here we have electrolytic capacitor, and then we have ceramic capacitor. This one is the ceramic capacitor, and then we have the pad, as you can see. here we have the pad or the test point. Okay, so here we get 3 volts. As you can see in the multimeter, we check this inductor, we get 3 volts. Okay, so basically this is the 5 volt channel here, where we have inductor, capacitor, the test point and external capacitors, and 3 volt channel here, where we have, as you can see, inductor, external capacitor and test point. So as you can see here, also when we check the capacitor, okay, here basically this circuit is zoomed in over here. Do you see? This capacitor is this one. So always the black probe in the ground and the red probe in the positive terminal of the capacitor. As you can see here, we have here the positive terminal of the capacitor. Okay, we have negative terminal. This color means negative terminal, and here we have positive terminal. Do you see? We get here 3.3 volts for this capacitor also, because this capacitor, as you can see over here, is connected to inductor and connected to 3 volt power rail. Okay, so we get 3.3 volt here in the inductor, this inductor, and also in this capacitor, as you can see here in the schematic. The same thing for the pad also. So we check 3.3 volt here, it's okay, here it's okay, and for the pad or the test point, as you can see over here and over here, we get 3.3 volts. Okay, means this circuit or channel is good. Now we're gonna use the same working principle and check the 5 volt circuit. Okay, we're gonna check also the 5 volt circuit. So we should find 5 volt here in the inductor and also in the electrolytic capacitor. Here we have positive terminal and also in the test point. Basically, just I teach you how you can take measurement, but if you check, for example, just the inductor and you find 5 volt, so it's enough. Okay, or you check the pad or the electrolytic capacitors. When there is, for example, a short circuit in the motherboard, you will find that here you will measure 0. So as you can see here, always the black probe in the ground and the red probe, we put it in the inductor. This inductor basically is, as you can see, is this inductor over here. Okay, so this is basically a 5 volt channel. Okay, this is 5 volt channel. Okay, here we have inductor, here we have electrolytic capacitor, ceramic capacitor, we have the pad, and we will get 5 volt. So we get 5 volt, as you can see, 4.99 volts. So also when we check the electrolytic capacitor, as you can see here, here we have the electrolytic capacitor, we get also 5 volt in the multimeter. Okay, so for this capacitor, as you can see here, we have 220 microfarad, 6.3 volt. These characteristics are rated above it over here. You will find the same characteristic as we have in the schematic. Okay, so the same thing for the pad. As you can see here, we check the pad. As you can see, using the multimeter, we get 5 volt. Here we have the pad or the test point. So basically here, I want to add that. Why exactly we use this component here? So the inductor here has as a purpose to adjust the current of this 5 volt. Basically, it increases a little bit the current where it is not enough. Here, those capacitors are here to filter the current. Basically, this one, it filters the current in order to get a pure current, and this one is, it eliminates the noise in the circuit. And of course, we have here the pad where we can check whether we get 5 volt or not. So now we can see that this circuit, the 3 volt and 5 volt circuit, are okay. Why? Because we find that all voltages, means 3.3 volt, 3.3 volt and 5 volt are good. Okay, so why? So it's not important to check the input circuit. You should go directly and check 3 volt and 5 volt. When you find once again 3 volt and 5 volt are okay, means automatically here have to be okay. But if we find, for example, these 2 voltages are missing, then we should go back and check the input circuit. Because when this one is good, of course this one should be good, and when this one is not good, this one have obviously a problem. And of course, if there is a problem here, we cannot get here 3 volt and 5 volt. So this is the input circuit or the charge circuit where we have the charge IC, as you can see. And this is 3 volt 5 volt circuit where we have the 3 volt 5 volt integrated circuit with 2 channels. Okay, the charge IC circuit, as you can see here, we have the charge IC here. Here this is basically the battery connector, and here we have the DC jack plug. Means here this is the charge IC circuit. Okay, so but me as an expert on laptop motherboards repairing, I give you some secrets that you can use in order to gain the time, and don't waste time while troubleshooting or isolating the issue. So if you have, for example, no power, you can go directly and check the 3 volt and 5 volt circuit. Do not waste time over here and check this component, etc. Go directly and check 3 volt and 5 volt circuit. So if you find that the 3 volts and 5 volt are present, means automatically this stage, all these parts here are good, because the 3 volt and 5 volt, the presence of 3 volt and 5 volt means automatically that the charge IC circuit is serviceable, is good 100%. For example, here, as you can see, we put the black probe in the ground. Over here we have the ground, over here also we have the ground, and we put the red probe here in this inductor. This is basically the 3 volt channel, and here we have the 5 volt channel. Do you see? We put the red probe here, and we get in the multimeter 3.33 volts. As you can see here in the schematic, we have the inductor. This inductor is this inductor. This capacitor, here we have the capacitor. Okay, and this part or this test point, we have the test point over here. So please pay attention. Never waste time while troubleshooting or repairing motherboards, because as a technician or engineer, you have not just one motherboard or two, maybe you have 10 motherboards a day. So you should know about the tips, tricks and secrets on how to gain the time and spot directly the failure without wasting time. And sorry, and as I told you before in previous videos, for example, I show you in previous videos how to detect the short circuit in the motherboard in just 10 seconds. 15 seconds is maximum. You can give me any motherboard, whatever its type or difficulty, any shorted motherboard, and give me the multimeter. I can spot and detect the short circuit in 10 seconds maximum, or even 15 seconds. You can go back and check my videos. Okay, so let's continue with the part 2. So basically we have seen the 3 volt and 5 volt circuit, and of course I want to add here that let's assume, for example, that we didn't find here 3 volt and 5 volt in the 3 volt 5 volt circuit. So at this time we can go back here and check the charge circuit. So what we have exactly in the charge circuit? So we have the power jack plug, basically this power or DC jack has an extension. These two cables, as you can see, these two cables are high, hold 19 volts. These two pins is connected directly to these two cables, and these two pins are ground connected to these two cables. Here we have an inductor that hold 19 volts. Here we have a switch. This is a MOSFET, but we called it a switch. Why we called it a switch? Because it switches just 19 volts from drain to source, or from source to drain. So depending on the type of the MOSFET, is it NPN MOSFET or PNP MOSFET? I will show you all this in the next lectures. So what we have here, you can check just this plug, whether this, as you can see, terminals are connected directly to the motherboard or not. If there is a drive, for example, you should make a little bit solder. Okay, here we have inductor. This inductor, basically you should of course check it using the multimeter. The inductor, the good inductor is the inductor that gives the continuity or the buzzer using the multimeter. We have a switch, so the switch, it will take 19 volts and give here 19 volts. So you should find here 19 volts and also here 19 volts. Basically here we have source and we have drain. Do you see this white mark? Means this is basically the gate. I mean gate. Here 3 pins for source, this pins for gate, and over here we have drain. So here we will get 19 volts because these 3 pins are connected directly to those pins, and the gate will receive a control signal, of course, from this IC, the charge IC, and we will get 19 volts. Okay, and of course we have here some other component like a transistor, we have Zener diode to stabilize the current, etc. Okay, so here we gonna see other thing. So for the short circuit, for example, we want to check this motherboard, is it shorted or not? So we will use here the adapter, but I advise you to use adapter with LED over here, like adapters for deal, for example, they contain LED. But if you have adapter without an LED, you can just buy any other adapter with an LED, okay, in order to see exactly the LED, the on-off state in the LED. Okay, so here we have the motherboard. Basically this motherboard is shorted, so once we connect this adapter here, this, as you can see, LED will shut off, will turn off. This one and this one means automatically that we have the short circuit here. Okay, so let's check right now. Do you see? Okay, do you see? As we connect the charge or the adapter in the motherboard, this LED turns off. So this is basically a note, or a rule, not a note. I consider this is a rule in laptop motherboard repairing or computer motherboard repairing. So where you insert the adapter, as you can see, and the LEDs of adapter or for laptop turned off, means 100% the motherboard is shorted. Okay, so this is a rule. Okay, so let's continue. So let's try again. So please pay attention to these two LEDs. Okay, oops, as you can see. So as you can see, the LEDs are off. Means that the motherboard is shorted. So here we will begin the detection process of the short that I have already explained to you. Please go back and see my videos and you will understand exactly how to check the short circuit easily and quickly. But no problem, I will make a summarize right now. So if you have a shorted motherboard and you want to check for the short circuit, what should you do exactly? So basically you're gonna use the inductors in the motherboard. So here we have inductors, as you can see. Do you see inductor? So because the inductor can never be connected to the ground. As you can see, always inductors exist in the power rail. So this inductor exists in the 5-volt power rail, this one, and this one exists in the 3.3 volt power rail. So the inductors can never be connected to the ground. And of course, this inductor, as you can see here, is into charge IC circuit. So the inductors, please remember this tip. The inductors in laptop or computer motherboard can never be connected to the ground. Never. Always the inductor are connected to power rail. Okay, are connected to the power rails. So once we know this tip or this rule, then we can use inductors to detect whether we have the short circuit or not. For example, let's assume we have this inductor here. This inductor is connected to plus 5 volt. Let's assume that we check using the multimeter between this inductor and the ground, and we find a very low reading, or we hear a buzzer in the multimeter. Means what? Means over here we have the short circuit, because normally we should get here 5 volt, okay, or 3 volt depending in the channel, but we get 0 volts, or we get a buzzer, basically not 0 volts, but we get a buzzer, we get a very low reading, because to check for the short circuit you should put the multimeter to the buzzer option, okay, to the buzzer option. Once we get a buzzer, means we have a short circuit. So the short circuit obviously could be this capacitor or this capacitor, because these two capacitors are connected to the ground. Over here we have the ground. It could be also the MOSFETs, it could be also the IC. Okay, so to check or to find the short circuit, always use the inductors. This is a secret that many technicians and engineers didn't know. They just look for the short circuit by checking all components in the motherboard, by checking the diodes, etc. No, never do this. I told you that you can detect the short circuit in just 10 seconds. As you can see here, we have how many inductors could you find in the motherboard? I mean big inductors. We have 1, 2, 3, 4, 5, and of course you could have other for the CPU, 4 for the CPU, and others for chipsets and for RAM. Basically about 10 inductors. About 10 inductors, big inductors. So you will put the red probe or the black probe in the ground and check the 10 inductors using the red probe of the multimeter. Check this one. No reading, the reading is good. Check this one. The reading is good. This one, until you find a very low reading and or a buzzer. 10 seconds is enough, or even 15 seconds, and you will spot the short circuit. Okay, so once, for example, you find that you have, for example, a short circuit here in this circuit. For example, you check this inductor, you hear a buzzer, means you have short circuit, not here, not here, not here. You have a short circuit in this part, in this circuit. Of course, it could be here, but the short circuit about 90% will be here, because you find this inductor, for example, is shorted. So once we find this inductor is this one, okay, this one is this one. Once, for example, you get the short circuit, you should then check all components that is connected to the ground, including this capacitor, the IC over here, this one, and the MOSFETs, basically, because under this channels here we have 2 MOSFETs. Okay, so this is how you can detect and check whether you have a short circuit in the motherboard or not. Okay, so now basically this is the whole circuit for 5 volt and 3 volt, where we have the 5 volt channel and the 3 volt channel. So let's see right now an animation, okay, of 3 volt and the 5 volt circuit, and then I'm going to explain you and to study the circuit one by one. So let's see the animation first. So what you have say here basically we have the 3 volt and 5 volt circuit. Okay, so here we have 5 volt and over here we have 3 volt. So this part is the 3 volts, as you can see, channel. We called it 3 volt channel, and this part we called it 5 volt channel. Okay, and we have the responsible here, the big boss or the control IC that controls this channel and this channel. Without this IC, nothing will be happened over here. Of course, all components are essential and are important, but this is the control IC here. Okay, so in order to generate 5 volt and to generate 3 volts, we need the control IC, as you can see here, TPS 51120. Okay, if you go to Google and look for this reference, you will find that this one is the control IC of 3 volt and 5 volt circuit, and of course you will find pinouts, etc., and requirements, etc. We need also 2 MOSFETs for each channel. Of course, these 2 MOSFETs also are very important. We will need capacitors. We have here 2 capacitors for 5 volt channel, and here also we have 2 capacitors for 3 volt channel. So the purpose of these capacitors is to filter the current or the voltage in order to get a pure and a clean voltage. Okay, basically this is a polarized capacitor. We have here plus and minus. This is electrolytic capacitor, and here we have ceramic capacitor. This one is here to eliminate and to remove the noise in the circuit. So the same for here. We have one electrolytic capacitor and one ceramic capacitor. Okay, then we have what? We have basically the inductor. Okay, so the inductor is before these 2 capacitors. We have also here inductor L4 and L3. L3 for 5 volt, L4 for 3 volt. So the purpose for this inductor is to adjust the current. And to get here the right current. So it basically, in general, the inductor increase a little bit the current if the current is not enough. Okay, then we have the pad. We have here pad 2 and here we have pad 1. So the meaning on the purpose of the pad in every circuit is what? Basically the pad is like a bridge. Okay, you can move it. If we move, for example, the pad here, we will isolate this circuit from this part. Okay, but for us as technicians and engineers, we use it usually as the test point, because if you want to check here whether we have 3 volt or not, you should check the pad here or the pad here, or even the inductor or the capacitor. Okay, so here basically we have 19 volts. Here we have 19 volt, and over here also we have 19 volt. So this 19 volt will be applied to this capacitor and to these 2 capacitors for this channel. Those capacitors will eliminate the noise from the signal, and then here the 19 volt will be applied here and here in the drain of the MOSFET, as you can see. Okay, so it will be applied here in the drain in the MOSFET. Okay, so here we have the drain. Okay, and here we have the source 3 pins, here we have the source 3 pins, and over here we have the gate. The gate is connected directly to this IC. Also here the gate is connected directly to this IC. So once the IC deliver or generate the control signals, as you can see here we have drive, as you can see, do you see drive high for this one, and here we have, as you can see, drive low for this MOSFET also. The same here, it will deliver it or generate drive high 2 for this MOSFET, and drive low 2 for this MOSFET. So once this 2 MOSFET receives the control signal, then this 19 volt will pass to the next step, but we will get here 3 volt and here 5 volt. I will explain you how. So let's say as you can see. Then once these two MOSFETs receive the control signal, the 19 volt becomes here 3 volt and here becomes 5 volt. So here we have question, how 19 volt here becomes 3 volt and here change to 5 volt. So please answer me in the comment. I want your answers in the comment. Okay, I will give you about 24 hours and I will answer in the comment below, and I will pin the answer. I will pin the answer, you know, as a first comment, but I want please your answers. How can 19 volt be changed to 3 volt here and here to 5 volt? So what is the action that is happened here in order to have these results? Okay, so please answer me in the comment below. I will give you an answer after 24 hours or even 12 hours, no problem. Okay, and even I will explain you the answer in detail in the next video. The next video will be the next video basically I will upload it today in the same day. Okay, but please answer me. Okay, so then we will get here to 3 volts. So this 3 volts will pass through this inductor. Okay, this inductor will adjust the current of this voltage, and then it will pass through this capacitor in order to filter the currents, and of course to make it a continuous current. Okay, this one will eliminate the noise, and here we will get 3 volts, 3.3 volt, a very pure and clean 3.3 volt that is ready to be applied to motherboard components. Okay, and of course you can use the multimeter and check whether you get this 3 volt here or not. So the same here, 5 volt will be applied to this inductor, adjusting the current. We have filtering component. You can check using the multimeter in the pad whether you get 5 volt or not, and over here we will get a pure and clean 5 volts. That will be applied also for other component in the motherboard, like for example for the hard disk drive motor, for optical disk drive motor, for USB connectors, etc., etc. The same for 3 volt, it will be applied of course for mini connectors. It will be applied for the BIOS, basic input output system, the pin number 8 of the BIOS, because the BIOS, the working voltage for the BIOS is 3 volt, also will be applied for the super IO, etc., etc. So please guys, follow with me and subscribe and activate the notification in order to receive any coming video, because I will explain for you everything on how to repair laptop motherboard step by step using the schematics. I will give you my experience. I told you before that I have a large and a huge experience, especially in laptop motherboard repairing using schematics. I repaired over 2,000 laptop, so I gained a very huge experience that I want to share it, to share with you my experience without limit. So please don't forget to subscribe, like the video, and share the video for other people like you that are interested in this field. And of course, please, for anyone who want to join me in the Patreon page, you are very welcome, and you are free, of course. You can join me or not. Anyway, in the Patreon page, I share and upload other content like tips, tricks, and secrets on how to repair laptop motherboards. And of course, I upload laptop motherboard schematics that you can upload for free. Thank you very much, and please answer me in the comment below why we get here 3 volts. Basically here 19 volt become here 3 volt, and 19 volt here become 5 volt. Why we get this value here. So I will let you see do animation again. So let's see another time the animation, as you can see here, of 19 volt. Okay, so 3 volt and 5 volt circuit, as you can see. Okay, now we get here 3 volt and 5 volt. So from, of course, 19 volt we get 5 volt and 3 volt. And in the previous video I give you a question, or I can consider it a homework. This question is what exactly? So as you can see here, we have 19 volts. Okay, here we have 19 volts in the drain of this MOSFET, and of course 19 volt also here in the drain of this MOSFET. So basically here we have 5 volts. So this is the 5 volt channel, and over here we have 3 volts. So here we have the 3 volt channel. Okay, so this is basically the 3 volt 5 volt circuit. Again, one of the most important circuit in every motherboard is 3 volt always and 5 volt always. Without these two voltages, nothing will be happen or okay with the motherboard, because based on this voltage 3.3 volt and 5 volt, other voltage are exists and generated. Okay, here we have 19 volt. Okay, this is the input voltage, and here as you can see we will get here 3 volt, and here we will get 5 volt, as you can see. So let's see the animation again. As you can see here we have 3 volt, from 19 volt to 3 volt, and from 19 volt to 5 volt, and of course using the same, as you can see, the same component, same MOSFETs. As you can see here we have the same reference of MOSFET, and over here same reference of MOSFET, and we got here different voltages. So why and how? Easy. So let's analyze a little bit the circuit. What we have exactly in the circuit? We have something that is very important, as you can see, the IC. We called it the controller IC. The controller means what? It controls the signals, the amount of signal and voltage that is applied to each component here, especially MOSFETs. Okay, so its reference, as you can see here, we have TPEs 51120. So this is the control IC. Okay, so this IC basically control this two MOSFET for 3 volt 5 volt channel, and also this two MOSFET for 5 volt channel. So if you focus here, you're gonna see. So let's try to remove 3 volt here. Okay, so here if you focus, we have, as you can see here, the drive high. Do you see the drive high? And also here we have the drive high. So drive high 1, as you can see, is applied to the gate of this MOSFET, and drive high, or drive high low, as you can see, is applied to this MOSFET over here. So let's first speak about the 5 circuits, 5 always channel. So when we have here 19 volts, okay, let me do this. Okay, okay, now here I have 19 volt over here. So once we have 19 volt into drain of this MOSFET, so this IC will generate a drive high signal, okay, to the gate of this MOSFET. Basically, this control or this signal is a specific amount of current that will be controlled, or that will control this MOSFET in order to generate 5 volts. In order to transform 19 volt to 5 volt. And for this channel, this MOSFET, we're gonna get here 3 volts. So the amount of current, okay, that we will get here in the gate is not like this one. This one will be higher than this one. So the control signal here, for example, let's assume that we have here as a control signal 1.5 volt. Example. So here, normally, for example, we should get 1.2 volt or 1.1 volt. So let's make it easy for you. Let's assume that in order to generate 5 volt here, the control signal here in the gate should be 5 volt. So the control signal will be here 5 volt, we will get here 5 volt. And in order to get here 3 volt, the control signal should be 3 volt. Okay? Do you understand a little bit? So this is how the MOSFET works. Basically, the MOSFET is a switch. We called it sometimes a switch or a bridge. Just it respects the control signal or that is applied to it. Okay? So, and sometimes the MOSFET, sometimes we have here 19 volt. It could give here as output 19 volt. So here or this state, okay, happened in the input of the motherboard. Next to the power jack, we have switches. It takes into drain 19 volt and gives 19 volt. We call it switches, okay? So that's why we get here these two voltages, 3 volt and 5 volt, due to the control signal over here. And of course, these two voltages will be applied, as you can see, to this inductor. We have here two inductors for both channels. Basically, these two inductors, L4 and L3, are here as a purpose to adjust the current of these two voltages or current. Okay, they adjust the current, and usually they increase the current a little bit. Why? Because the current is consumed, because the current that we have here, for example, will be consumed a little bit about these lines or path and the components in the motherboard. That's why here we have inductor in order to compensate or adjust or increase the current. Okay, after that we have capacitors. For this channel we have two capacitors, one electrolytic capacitor C21 and another ceramic capacitor C22. Here also we have two capacitors, filtering capacitors C43 and C53. We have 330 microfarad as a capacity of this one, 4 volt, and over here 1 microfarad, 10 volts. Okay, so this capacitors here has as a purpose to make the signal or the voltage a pure voltage or a clean voltage. Basically, this one filter the voltage in order to get a continuous voltage, and this one, the ceramic capacitor, as you know, always ceramic capacitors remove or eliminate the noise from any circuit. Okay, so then what we have here, we have the pads. As you can see, two pads over here. We have pad 1 for 5 volt and pad 2 for 3 volt. So basically here pads, for me I use pads as a test point. For example, if you want to check whether you get 5 volts in this channel or 3 volt in this channel, you should use the pad. Never go and, for example, check here in the integrated circuit pinout or MOSFET pinout. You could make a short circuit. Go directly and check the pad. The pad is isolated from other component. It's easy to take measurement or make measurement using these two pads. Okay, and of course we will get 5 volt and 3 volt. So this is how the 3 volt and 5 volt circuit works. And of course all circuits in the motherboard has the same working principle. If you understand just one circuit, you can understand and analyze and of course troubleshoot and fix any motherboard you get. I mean, if the motherboard is it old motherboard, or newer motherboard, etc. Because many of my followers ask me why you use old motherboards to teach us or to make videos. So they say me please use an advanced, a very newer motherboards. So my response for my followers, my loyal followers, I respect you, but as a technician and based on my experience, the beginners people or followers will understand easily and rapidly or quickly by analyzing old motherboards, because in old motherboards everything is separated and you can understand it easily. But into advanced motherboards, for example, all chipsets are integrated in just one chipset. We don't have CPU alone, ICH, not bridge, graphic card alone. No, all chipsets are integrated in just one chipset. How can a beginner understand what is the GMCH, what is ICH, what is graphic card? No, me, I prefer old motherboards, and if you understand old motherboards, 100% the advanced motherboard will be easy for you. Okay, so here, as you can see, this is basically a real motherboard where we have the circuits. We have seen the circuits in the schematic. Now here we have the circuits, real circuits. This is basically 3-volt channel, and over here we have 5-volt channel. So, and in every channel, as I told you before, you're going to find some components that are mandatory and obligatory for every channel in the motherboard. So these components are the control IC. The first component is the control IC. Do you see here? We have TPS 51120. The same as we have seen in the schematic. If we go back, here we have TPS 51120. Okay, the same IC. Okay, so this is the control IC, and of course around the control IC you're gonna find, as you can see, many components, and me, I focus always in ceramic capacitors. I like ceramic capacitors. This is among the very important component in every motherboard, ceramic capacitors. Why? Because ceramic capacitors always help me to troubleshoot and isolate the failure. Okay, for example, if this IC is shorted, okay, you cannot do a measurement directly on this IC. You cannot check it using the multimeter easily, like a resistor or ceramic capacitor or a diode or Zener diode. No, it's not easy to check it. You can use the 3 methods that I shared with you in the previous video. The first method, by the 3 methods that I want to remember and stick in your mind are the 3 methods that we use usually when we want to check whether an IC is good or not. The first method is by checking the heat of the IC using, just by touching its body or using your finger, or of course if you have a thermal camera, it's okay, you can use it and check the heat of the IC. This is the first method. If the heat is not normal, is very increased, automatically this IC is damaged. Replace it without any options. Okay? The second method is what? Is by checking the ceramic capacitors around it. That's why I told you that ceramic capacitors are very important. Are very important for any technician. We use it to troubleshoot and to identify the short circuit, okay, by using ceramic capacitors. This is the third method. So if you find, for example, that this one is shorted and this one is shorted and this one is shorted, means what? means this IC is shorted. Why? Because always the ceramic capacitor is connected to the IC. Do you see the path in one side and to the ground in the other side? This one is connected to the IC in this side, to the ground in other side. The same for this one. Okay. So the ceramic capacitors helps us to identify whether the IC is good or not. And the third method, okay, is by checking the inputs and the outputs. This is basically a very advanced method that I use, of course, but I prefer the second method, ceramic capacitors. As a beginner, try to use the first method by checking the head, and the second method by checking the ceramic capacitors around the IC. But for the third method, just for advanced people. Why? Because here you're going to check the inputs and the outputs using the multimeter, and of course with motherboard power on. And of course, to do that, you should get and have the data sheet or the schematic of the whole motherboard, or just the data sheet of the IC, and checking the inputs. If you have all inputs and the outputs are missing, means the IC is bad. But if you have a missing input, means the IC is not bad. You should look for the input first. For example, here we have the input voltage, 19 volt. Here we have the enable signal. Here we have the clock signal, the shutdown signal. Here we have the power good signal. The power good, for example, should be 3.3 volt. And we find 0 volt. Means what? The power good is an input. Is that mean the IC is bad? No. We should first get the power good, the 3.3 volt, and then judge whether this one is good or not. Do you understand me? Okay. So basically, the component that is important in every circuit, we have the IC. If we go back to the schematic, we have the IC, MOSFETs. Okay. So inductor here, under the voltage we have inductor. Okay, so we have here inductor and their capacitors, and of course the path where you can spot and check whether you have the right voltage or not. Okay, so here, as you can see, we have the IC, we have the inductor for these two channels. For 3 volt channel we have the inductor, and also for this channel we have inductor. Okay, over here, then what we have capacitor. This is the electrolytic capacitor for 3 volt channel, and also for 5 volt channel we have electrolytic capacitor. Then we have ceramic capacitor next to the electrolytic capacitor, as you can see, C22. And of course here also we have ceramic capacitor here. Okay, and then we have the pad. Do you see the pad here? We have pad 1. Here you can check whether you get 5 volt or not. And the pad basically for the 3 volts is somewhere here. Okay? Okay, please, if you don't understand it, try to repeat it for the second time, or even 3 times, or even more, because this is the principles, this is the basic or the working principle. If you understand this video, you're gonna understand any circuit, and you will of course troubleshoot and fix any motherboard. Because for example, let's assume for example that for this motherboard I have problem in this circuit, in 5 volt 3 volt circuit. Easy. First I should locate and identify the main component, including the IC, the MOSFETs. Okay, for the MOSFETs, as you can see, here we have capacitor, here we have inductor for 3 volts. Okay, and for 5 volt circuit we have inductor, we have 2 capacitors. Here we have the IC. The MOSFETs are in the back of this channel. Okay, so here I have a problem. Means what? It could be, the problem could be here in the IC. The IC is bad or shorted or doesn't deliver or generate the control signals for this MOSFETs, or the problem can be in this one of these 2 MOSFETs, or the problem can be one of this capacitor, those and those, one of them are shorted or not. So if I check, for example, the pad here and I didn't find 5 volt, means I should troubleshoot this one, the IC, by checking the head of the IC, by checking the ceramic capacitors. I should be sure that these 2 capacitors are good or not, and the MOSFETs in the back also are good or not. Okay, so this is easy. So thank you very much, guys. We're gonna see the rest of the course in the next video. Basically, this course is a very huge course, because in this course I will cover everything you can imagine, okay, in laptop repairing in this course. So if you follow with me, you will understand everything: troubleshooting the short circuit, troubleshooting no power motherboard, no data motherboard, problem in the charge circuit, no charging motherboard, etc. Please, for anyone doesn't yet subscribed, don't hesitate to subscribe for incoming videos, and please don't forget to share the video and like the video. And of course, for anyone who want to join me in the Patreon page, you are very welcome. You are free. If you want to join me, you are free, of course. There I upload in a daily basis many laptop schematics, many useful content, tricks and tips on how to repair laptop motherboards, etc. Thank you very much, and please comment below if you have any question. Post it in the comment below. Thank you very much, and see you in the next video.